Hello students, welcome to my YouTube channel. I am Shlok Kulkarni and today I am going to teach you how to solve questions from Descent chapter in Keith Williams' Gen Nav book. Very important questions as far as CPL and ATPL exams are concerned. I have already solved many questions from this chapter, particularly first 60 questions, and already uploaded them to my YouTube channel. Do watch them if you haven't yet. Let's start with question number 61. If there is a 5 knot increase in headwind, what amount must the rate of descent be changed in order to maintain a 3-degree glide slope? So, increase in headwind will result in increase in the rate of descent excessively, right? Aircraft will find itself below the glide slope. The solution to this problem is the pilot must increase his engine power and arrest his rate of descent. Okay, excessive rate of descent, and bring aircraft back to its normal rate of descent. Okay, so the change in rate of descent required is equal to 5 times the change in the speed, ground speed. So 5 times. Now whenever there is an increase in headwind, the ground speed will decrease. So if there is 5 knot increase in headwind, the ground speed will decrease by another 5 knots. So 5 into minus 5, so that is minus 25 feet per minute. So the rate of descent must be decreased by 50 feet per minute. Okay, next. What will be the rate of descent when gliding down a 5.5% slope at a speed of 450 knots? So glide slope equals to tan theta into 100. So 5.5% equals to tan theta into 100. So tan theta equals to 5.5 divided by 100, which is 0, 0.055. So theta will be equal to tan inverse 0.055. So tan inverse 0.055 is equal to 3 degrees. So use this in the ground speed formula. Ground speed into rate of descent equals to glide slope into speed into 101.3 feet per minute divided by 60. So 3 degree into a ground speed of 450 knots into 101.3 divided by 60. That is equal to 2279 feet per minute. At 4 o'clock, aircraft is at flight level 370. 420 knots is the cruising speed, is on direct track towards a VOR which is 185 nautical mile ahead of it. The aircraft is required to overfly VOR at 8,000 for a rate of descent of 1,800 feet per minute and a descent speed of 250 knots. The latest time at which to start descent is what? So here is your VOR station. Here is your aircraft. Okay. So currently you are flying. Currently you are expected to fly straight and level for some time. Then after reaching your top of descent, you will begin your descent towards this VOR station. You are a total of 185 miles away. Current timing is 4 o'clock. Speed, cruising speed of your aircraft is equal to 420. Descent speed of your aircraft is 250. Rate of descent is 1,800 feet per minute. Okay. Now let's solve this. Now rate of descent is 1,800 feet per minute, right? So rate of descent is nothing but change in height divided by time. So 1,800 feet per minute equals to change in height. So we are descending from 37,000 feet to a height of 8,000 feet. Okay, 37,000 से लेके 8,000. So the height difference is 37 minus 8, that is 29,000 divided by time. So let's find out the time taken to descend that much. 29,000 divided by 1,800, which is equal to 16 minutes. Okay, so this is the time taken to descend from 37,000 feet to 8,000 feet. Now that you know descent speed, your time required to descend, you can calculate distance covered during your descent phase. Okay, you can calculate the horizontal distance covered by aircraft as it travels from top of descent to the VOR station, this horizontal distance. Let's use speed distance time formula. Distance is speed into time. So descent speed 250 times 16 minutes divided by 60 hours. So 250 into 16 divided by 60 is 66 nautical miles. So that means you cover a total distance of 66 miles in descending from higher level to a lower level. So the remaining horizontal distance is 185 minus 66, which is equal to 119 nautical miles. So your aircraft will travel for 119 nautical miles before it begins its descent. So what will be the time taken to travel this 119 nautical miles? Use your speed distance time formula. Time equals to distance divided by speed. So distance is 119, speed is 420, which is equal to 17 minutes. So your aircraft will have to travel another 17 minutes from this point to this point before it begins its stop of descent or before it begins its descent phase. So 4 o'clock plus 17 minutes is 0417. So it must begin its descent at 4 o'clock 17 minutes, 4 hours 17 minutes. Aircraft is maintaining a 5.5% glide slope. So convert that into angular measurement. Tan theta equals to 0.055, theta will be equal to tan inverse 0.055, which is 3 degrees. Now use the ground speed formula. Rate of descent equals to glide slope angle into ground speed into 101.3 divided by 60. So 3 degrees into speed. Okay, correction. So I didn't read the question carefully. So now 3-degree glide slope. So let's draw this. Okay, so it's a 3-degree glide slope. Your aircraft is here. We have to calculate, and we have to calculate the height of the aircraft. Horizontal distance is 9 nautical miles. So x. Let's use 1 in 60 rule. 1 in 60 rule says angle equals to distance off track divided by distance gone into 60. So x equals to 9 into 3 by 60. So 27 by 60 is 0.45 nautical miles. That is 2,736 feet. That means aircraft is 2,736 feet high. Using tan theta, we get tan of 3 degree equals to opposite upon adjacent. So 9 into tan 3 is 0.47 nautical miles something. Multiply that by 6080, you get 2868. So anyways, this is 2700, this is 2800. You're going to select an option which is closest to either of these values. If I not decrease in headwind, a decrease in headwind is nothing but is something like increase in tailwind. So if increase in headwind leads to excessive rate of descent, then decrease in headwind or increase in tailwind will lead to insufficient insufficient rate of descent. That means aircraft will find itself above the glide slope. It will come down towards the surface at a very slow rate. Okay, slower than expected, slower than required. So let's say this is your runway and this is your standard glide slope. Your aircraft is at position 1. At position 1, you are getting, let's say, 20 knots headwind. Then at position 2, your aircraft gets 10 knots headwind. So your headwind has decreased from 20 knots to a new value of 10 knots. So what will be the impact or what will be the result? Your aircraft won't be able to maintain this 3-degree glide path. Its rate of descent will decrease, it will reduce. So instead of descending, continuing this descent down to the threshold, it will it will remain suspended in the atmosphere for a bit longer time. Okay, so this will be it. Okay, so this will be its trajectory of motion. So what will be the solution? The solution is the pilot must anticipate and decrease engine power so as to increase has to increase his rate of descent. Now, by what amount will the pilot increase the rate of descent? So, change in rate of descent equals to 5 multiplied by change in speed. So, 5 multiplied by, there is a 45 knot decrease in headwind. It will be accompanied by 45 knots increase in ground speed. So, plus 45 ground speed. So, that is 225. That means the pilot will have to increase his rate of descent by 225 feet. Next, feet per minute. 67. Aircraft is at flight level 350. It has to descend over VOR at flight level 80. Distance is given, speed is given, what is rate of descent? So, rate of descent equals to change in height divided by the time taken. So, descending from 35,000 to 8,000 will be equal to a height change of 27,000 feet. Time. Now, time taken is distance divided by speed. So, 105 miles divided by 370 knots. So, 105 divided by 370 is equal to 17 minutes. So, 27,000 divided by 17 is 1588 feet per minute. Okay. So, this is your answer. Glide slope speed 400 knots, glide slope 7.5%. Rate of descent is how much? So, slope equals to tan theta into 100. So, 7.5% equals to tan theta into 100. So, tan theta will be equal to 7.5 by 100, which is equal to 0.075. So, theta will be equal to tan inverse 0.075 is equal to 4.2 degrees or 4.3 degrees. So, rate of descent will be equal to glide slope angle of 4.3 degrees into speed into 101.3 feet per minute divided by 60. So, 4.3 degrees into speed of 400 knots into 101.3 feet per minute divided by 60. So, 4.3 into 400 into 101.3 divided by 60 is 2903.9. So, 2904 feet per minute. That is your rate of descent. Next. If there is a 65 knot decrease in headwind, again a decrease in headwind means decrease in headwind. That means you will have to increase your rate of descent. Okay. So that increase in rate of descent will be equal to 5 multiplied by change in ground speed. So 5 multiplied by. So a decrease in headwind will lead to an increase in ground speed. So 5 into plus 65, which is equal to 325 feet per minute. So you will have to increase your rate of descent by 325 feet per minute. So let's say you're descending at 500 feet per minute. Okay, 500 feet per minute is the standard rate of descent on a 3-degree glide slope. Let's consider this. In the event of a tailwind, you will have to increase that rate of descent from 500 to a new value of 800 feet per minute. 500 plus 300 approximately 800 feet per minute. This 800 feet per minute will enable you to maintain that 3-degree glide slope. Okay. Aircraft is at flight level 290 and it has to descend to a new level of 80. Distance is given, speed is given, what is the rate of descent? Again, rate of descent equals to change in height divided by time. So change in height is 29,000 minus 8,000, that is 21,000. Now time taken. Time taken is distance divided by speed. So 75 miles divided by 290 knots, which is equal to 15 minutes. So 21,000 divided by 15 is equal to 1,400 feet per minute. Simple. Equivalent of 170 meter per second is what? So 1 knot equals to 0.515 meter per second. So 170 meter per second equals to 170 divided by 0.515, that is 330 knots. 330 knots. Simple. So we'll stop here. In the next video lecture, I will solve the next remaining questions 71 to 80. I hope you have understood all the 10 questions that I have solved in this video lecture. If you need further clarification, let me know in the comment box. Thank you for your time. Best of luck. See you in my next video lecture.